Other types of compounds that you will learn to name are acids. Acids are molecular compounds that have hydrogen at the beginning of the formula. There are several ways that we can define an acid. One is the Arrhenius definition, which says that acids are any substance that donate a hydrogen proton in a solution. This is called dissociation, which means the hydrogen separates from the rest of the acid. A strong acid will dissociate or come apart completely. An acid also has to be in a solution with water, which is what we call an aqueous solution. When we write the formula for an acid, the hydrogen comes first. The subscript on the hydrogen depends upon how many hydrogens are needed to balance out the other part of the acid. The two categories of acids are binary acids and oxyacids. When looking at the formula, you need to ask, does the formula have an oxygen? If yes, then it's an oxyacid, an example of which would be nitric acid. If there is not any oxygen, we call this a binary acid, and an example of that is a familiar acid, which is hydrochloric acid. When looking at the formula for a binary acid, it will typically contain two elements, but more importantly, no oxygen. In the name, hydro always comes first, followed by the stem plus ic, and then the word acid at the end. For example, if you have the formula HCl, then you would start with hydro, the stem would be chlor, with ic as the ending to make hydrochloric acid. Take a look at the examples that are given, write them into your notebook, and we'll go over them. So you have a few examples to look at. Notice that each of them all have hydro at the beginning, and then the stem of the name with an ic and acid. Okay. The last one, hydrosulfuric acid, notice that the name is a bit of an exception, and we don't drop the UR at the end. We keep the entire name and add the ic at the end. The next type of acids, oxyacids, will look familiar due to the formula similar to the polyatomics. To determine the naming conventions, you first need to determine what the oxyanion name is. If the oxyanion ends in "ite", like sulfite, then the name is the stem plus us. You always add an acid at the end. If the oxyanion ends in "ate", like sulfate, SO4, 2-, then the name is the stem plus ic, and then again add the acid at the end. Examples of these would be if you had the formula HNO2, it has nitrite in it, so the stem plus us would be nitrous, and then you add the acid to be nitrous acid. The example for the 8 version would be HNO3, which has nitrate. You would take the stem plus ic to be nitric, and then add acid to be nitric acid. Notice that there are not any hydros for the oxyacids, only the stem plus the ending plus acid. Take a look at the examples for oxyacids, write them down, and see what you think. For the first example, the oxyanion would be named sulfite. This means that the ending should be us, or to make sulfurous acid. The next one is sulfate, so you would change the ending to ic and get sulfuric acid. The last one, where it asks you to give the formula for hypochlorous acid. This means that the polyatomic would be hypochlorite. You have "ite" as the ending, so it becomes us, and then you have the hypochlorous acid. Hopefully this makes sense as you are familiar with other types of namings. What I would like you to do is think about it. If you have any questions, write them down. If you don't, then go ahead and write down a nice summary sentence for what you learned about how to name acids.
Created using Powtoon.